So the next part of this process, basically, and I'm just doing this all live really, is set r equals requests here, and I've actually run it, and it looks like it's run perfectly fine. And I'm getting this literally from I just pulled it up on GitHub over here, so I'm literally getting it out of here, where you can import requests. Request is a module request is a module just for downloading stuff off of the web. I'm not going to do it exactly in this format, but basically you can do like r equals requests. They got request equals requests here, and then get the URL. So you just have to. It looks like you just have to specify the raw GitHub URL, and then there is an if statement and so forth in here. I may or may not do that. Let's have a little bash of it actually. Let's actually do we'll see if our status code works. So if r dot status, I don't like the fact that it's not actually popping up status, because the IntelliSense doesn't look like it's working. I might hit a refresh just to make sure that everything works here. Let's have a look. We'll do a restart, and not that one. I think that might do it. I'll do clear all outputs as well. So r dot no import requests should actually do that. But okay, let's just I'm going to stick this all in anyway. These are the sort of things that happen, and I kind of want it to be like this because the videos that are generally shown are sort of like the output ones that are quite nice and shiny, whereas you don't get to see the pane. Let's actually just do r dot status code and see what happens there. Yeah, we get a 200. So 200 status code is good. So I'll complete the rest of that because I presume this is the right way of doing it, and I'm not sure. Maybe I have to do like a full restart, so I might like stop this video and restart it and join it onto the next one. But yeah, it's not detecting my indentation or anything, so I'm not sure exactly what's going on there. But we've got to check there, and then sort of like print. Let's have a look. This works. This works! Exclamation mark, and see if we can run that. We didn't get this works. Okay. Okay, we'll just it looks like the requests thing isn't working for some way. That's a very odd one. I'll go and figure that one out then. Okay, so it looks basically like I actually just needed to do a restart. I don't know why, but like the clue is that if you're not getting the colors, like so you know the purples, and the request wasn't green and it wasn't popping up. So if you're not getting that in the IntelliSense, then for some reason the Jupyter Notebook is broken. I'm not like a huge fan of the Jupyter Notebook, but it's amazing for prototyping. So we're going to go that way. And actually, you know, the tutorials are kind of like in the notebook, so like for the same thing, and you can check that each point in time that everything works. So here we've imported this module requests, and the requests. We've got the request HTTP library written in Python for human beings, and it lets us you know, do this. So I could have actually kind of like copied this code here. The r.status code 200 tells us that everything's working there, and there's this if r.status code equals requests. This basically is a number 200. We could have stuck 200 in here, which is the same thing. Control Z. But we know that this works, but we don't want to have this works. What we want to actually do is read the file. So I guess we're going to get something like r.text just to make sure that we get the file out. So let's also print then, instead of this works, we'll change that to r.text. Yeah, so we get the IntelliSense working. That looks a bit better. So let's have a look and see if we get something back. Yeah, there we go. Okay, so that's the first part of it. We've got some text in there. Obviously this says output exceeds the size limit. The limit for the number of lines that you can have, I think, is about 30 over here. So, and obviously it's like hundreds and hundreds of lines. So what the what the Jupyter Notebook does is it actually puts in the first, like, 20 lines or something. Then it does these ellipses and misses out the next 10,000 lines or however many it is and puts the last few lines in. So it's a little bit cleaner, but it looks like the file has gone in there. And yeah, potentially we could sort of like count the number. I guess if we got r.text, we can do, we could probably count the number of words in this. So let's do r dot. I wonder if it's sort of like a count or a len. We'll do len of r. Len of r. So r should be in the memory. Length of r. No, okay, I've created a little error message there. Response has no type. Length, okay. Okay, fine. Let's just in that case say our text is equal to r dot text. Okay, so that should be better, and then we'll get the length of the text. So text. So we run that, and down to the bottom. There we go. We've got right, these 3 digits, then these 3 digits. We've got 1 million. We've got 1 and a bit million characters. That's what we've got. So the text that's coming here. First citizen, before we proceed any further, hear me speak, da da da, and so forth. This is like a million and a bit characters, so that's what we've got to work with in terms of the data set. I'm just going to add the else statement, and again, I'm literally just nicking that bit out of here, which is if you do have an if, you should put an else just in case it's not found. We'll have an else content not found. In fact, I'll take all of that because why not? And paste that over here. So we've got an if else content was not found. I like to use lowercase. We found our content, so everything works there. We won't actually, maybe we will print the text, why not? Because it's not actually printing that much. It's just truncating it. So, and I think at this point, maybe we move to our next block of code because I'll consider this piece done. So what we've done is start with a data set to train on. So I'm actually going to create a new block of code here, and we're going to, so we've read the text. So let's just now check out some data in the text. So check out the data. And so I might just take this piece here, this len of text, because we know that we can read it. So we've got the content over here, and we'll just check out the data. So let's do, we've got this one here. Let's do a print statement and print the length of the data. We don't even need the thing, so we can do that, something like this, because we know that this len func will work, so we can stick that in here, and we've got the length of the data that looks like this. Now, okay, it's a little bit awkward to read big numbers in Python. There is a way of getting the underscores underneath it, like with a formatting. I'll see if I can check that out, just because we'll possibly be working with big numbers the whole time. So I'm going to have a little quick sift of GitHub. Again, there might be a simple output that makes it look a bit tidier. So I think actually the first thing that I might actually try to do is I just put this in. I had an idea. Instead of going to GitHub, let's just have a little bash and see how good GPT is at doing this. Okay, we can use the format word. Here we go. So that's the general formulation of it. Format number. Okay. I don't like that, but okay, we've got a formatted number. Let's just do that just for the sake of it looking nice. So we'll take that. What this is we're going to have a number then. So number. Maybe we can actually stick it round this. So our formatted number. It looks like we can just wrap this in format. So I'll put an extra space, a few spaces here, just so that we can see what we're operating on. And I'm going to just wrap this because this has got to be wrapped into a format just like that. That's our number, and then over here we've got comma, and there we go. The little this is quite nice. It's popped up and helped us inside quotation marks. We want to put a comma underscore. I've used this before. It's just kind of like, this is a great reminder for how to do things. So let's just run it. No, it didn't like that at all. I'll have to come back on that. Okay, so I've just copied and pasted exactly the same code from, I've literally done here copy code and pasted it straight into here and run the same thing. So unfortunately it looks like ChatGPT spat out a wrong answer, so I'm going to have to, maybe I'll type in doesn't work, or I'm going to have to go to GitHub or something else to look it up to find out how to do it. Actually, I've just managed to get it to work just by deleting the comma. So that was partly reading through the docs, and actually I literally typed into GPT, this doesn't work, and then it said sorry. But in the meantime, I just thought I'd delete the comma. So that works. So I just have to delete the comma from here. So yeah, that works nicely now, and the length of the data is, and we can see clearly that we've got 1 million, 100,000 and so forth characters in there. So fantastic, we got that bit working too, which means I can delete this cell, and then we will move on to our next bit. So the next part is to extract the unique characters out of the text. I'm just going to run that again because I was testing something else, and this is our text, like, it's the thousand, not thousand, it's the million characters that come in here. So we're kind of like going to attempt to read that and get the characters from there, and it says text. So we can do text. We can do the set operation. We can get the set of these characters. If we run that, these are all the characters that exist in the million characters that are there. So that's everything that occurs, and set makes things unique. So build an unordered collection of unique elements, so nothing's going to be repeated there. So let's say, for example, there wasn't a capital A anywhere, you just wouldn't see it in the set. If there was 2 capital A's, you're just going to see one of them. So it looks like, well, again, we've got triple dots, so we can't see it all, but we're going to put it into a list actually. Maybe that will. So we'll do a list of the set because that's quite common. So we're turning this set into an array. Remember, these are both collections, sets and lists are collections. Let's just run that. That's turned it into a list, and then I guess we were going to sort the list. So sorted. So the sorter returns a new list containing all the items from the iterable in ascending order. So let's just kind of like run that, and that's everything in ascending order there. The \n is the escape character, which means a new line. There's a space that comes first, an exclamation mark is next. And I guess this is just the ASCII order of how things come in. So we'll assign this to the variable chars. We'll just call it characters. This is characters here. So that's all of the characters that are in the 1 million characters. This is all of the unique characters that are in the 1 million characters of the miniature Shakespeare data set. So the next bit that we're actually going to do is just count the size of the length of this set. So we can do len of chars, because that is this entire, but now it's not set anyway, it's actually a list. We can do the len of this list here, and when we do that we get 65. So, and we'll assign that to a variable. We'll call it the vocab underscore size. I'm actually getting this one from a previous tutorial. So this is a vocabulary size, and we can see everything in there. So we can print let's actually put 2 things, which is print the size is colon, and then we can stick in vocab size. So we've got the vocabulary size, and then let's also print out our entire set of data. So print the list is this, and I'm just going to print it out so like horizontally, otherwise we're going to get that big vertical list going down, and we get the 3 ellipses and we can't read it in the notebook. So the list is this, and maybe I'll do a \n for a new space there, and for a new line, so that it gets printed onto the next thing. And we just got to do I think it will be something like, if it works, that dot join. This is just an operation, so we're going to join our characters. So Charles. So hopefully this is going to take this characters variable. The dot join method here just does a concatenation, concatenates any number of strings. So it's going to sort of like join this list here, A, B, P, Q, R, S, and it's going to give us like this back basically. Here in the example they've used a dot, so we're just going to use we just got like a space or nothing there. I think that would be good enough, and let's just have a little run of that. And so the vocab size is 65, and presumably if we count this we would get 65 characters. So that's quite nice. We've got to that little part of it. And the whole process of this is basically literally to sort of like turn our data, everything that we like, all of this stuff here in the I keep forgetting what it, in the Shakespeare, in our little tiny Shakespeare thing, all of this million of characters, we're going to sort of like count them and do things with them and work on this data set. So that's basically the process in very simplistic terms of what we're trying to do. I guess one thing to note out of this, because I've actually just done a count of this. This is a whole alphabet, A, B, C, D, F, G, all the way to Z. So every letter in the alphabet there is capitalized, exists, and every letter in the capitalized in the lowercase alphabet exists. So like if we were to like go through this data set, we'd find a capital Z presumably somewhere in the million bits of data. So that's what exists. The first character here is a space. We don't like see it, but it's there, so space exists. And then we've got these characters here that are used, so like the exclamation mark is used, the full stop's used, minus and commas used. But what I notice is that no numbers apart from the number 3, and I don't know where the number 3 occurs. We could do a search for it, but there's no like 1, 2, 3, 4, 5, 6, 7, 8, 9, so no numbers. Shakespeare never used numbers, basically, at least in the mini Shakespeare with the a million of his characters. No numbers were used in that.